Number 1, the graph of a system of a linear equation and a nonlinear equation is shown. What is the solution, x, y, to this system? Right, so a solution to a system of equations just means where they cross. So this can be, you can have one solution, two solution, three, it's infinite really. If I had a parabola and a line, then I'd have two solutions there. Or I might have one solution or no solutions. In this case, they've already, done the graphing. A lot of these systems of linear equations, we would have to graph them or do the math to find where they cross, but they've been nice. They've given us that point of intersection, and it is right there. So we just have to be very careful that we're doing this as x, y. X is down here, and our y is the vertical. So our x is going to be 4, and our y is 5. So 4, 5 is our answer, and that is C. Something to note here, if you look at what they're trying to get you to do, you have like 0, 4, and 5, 0, these other answers. They're trying to trick you and say they're wanting you to find where it crosses the x or y axis, because if it is a single equation, linear or nonlinear, a lot of times we talk about solutions, we're talking about where it crosses the x-axis. So don't be pulled in by that. This is a system of equations. It's where they cross each other, wherever that is. Here it is, 4, 5. Number 2, on the first day of a semester, a film club has 90 members. Okay, so I'm going to write that over here. I'm going to say the first day, it has 90 members. Each day after the first day, 10 new members join the film club. All right, so this is the one day after. 10 more people join the film club, okay? If no members leave the film club, how many total members will the film club have 4 days after the first day of the semester? Okay, so I'm just going to write this out. So we have the second day after, the third day after, and the fourth day after. I'm not writing after all the way, I'm just writing aft. Okay, and so we know they're adding 10 new members each day. So let's do that math. Let's see, we had add 10 to get to 100, then 110, 120, 130. I'm going to double check and make sure that I read this correctly. 4 days after the first day. Okay, so 1, 2, 3, 4 days after. I've added 10 each day. It is 130. You absolutely could also do this as saying I had 90, and then I am adding 10 each day after, and there are 4 days after. You could do it that way. 10 times 4 is 40, and then we would say 90 plus 40 is 130. Whatever makes the most sense for you, however it's best to visualize it, but 130 is our answer, and that is going to be B. Number 3, the graph of the linear function f is shown where y equals f of x. What is the y-intercept of the graph of f? Okay, when we're looking for the y-intercept that's on a graph, we're just looking for where that function crosses the y-axis. And, this is going to be for any type of function. Parabola, it's always the same. The y-intercept is always the same thing. It's always talking about the same thing. Where does it cross the y-axis? So let's look here. And if we zoom in, we're up here in the positive y. There's where it's crossing. Come here, pin. There we go. That's where it's crossing the y-axis. I hate when I draw dots. It always does that. Do you want a note? No, I don't. I want a dot. Leave me alone. So what are the coordinates for this y-intercept? Our x-coordinate for the y-intercept is always going to be 0. And so here it is 0, positive 8. X comes first, and then our y is 0, positive 8. Let me zoom out so we can actually see the answers that are down there. There we are. And D is my answer. I'm surprised, honestly, that they didn't try like 8, 0 to kind of trip you up, and you just see the 8 and think that that should be correct. Be mindful of that on the actual SAT. They love doing things like that. Here, they were nice and they gave zeros as the x coordinate for all of your multiple choice answers. They don't always do that. So just be careful when you have something like this not to get them mixed up. That's the kind of careless error we've all made. Let's avoid those. Again, D08 is my answer. Number 4, S plus 7R equals 27 and R equals 3. What is the solution RS to the given system of equations? Okay, so this is a system of equations. It means we have two. I don't see any squares, like x squared, r squared, s squared, nothing like that. These are both linear. They are two lines. Okay, and it's just like an equation with x and y's, because we're told the solution is RS, just like in another one we would say it is XY. So you treat it the same way. Just treat it like you're solving a system of equations with X and Y. If you want to graph this, you can. If you do graph it and you're going to get, you're going to get two lines, you're going to get two lines that are crossing, you're going to be looking for the point of intersection. Personally, I think this one is straightforward enough that you can do it without graphing. I think it's a little slower to graph it. But if that's the way you want to do it, you do you. Okay, if we're going to do this without graphing, anytime we have a system of equations, we want to be thinking of substitution, elimination, or graphing. Here, substitution is my bet, is my choice, I should say, because I've already got a variable that is isolated in R. R equals 3. All right, I already know that R equals 3. Now, little side point here. I'm going to just, I'm going to show you how to do this, but there is a way you can just look at the answers that will help you at that point. Remember what I just said there, if R equals 3. We'll come back to that in a second. All right, so if R equals 3, then I look at that other equation, S plus 7R equals 27. I'm going to plug in a 3 wherever I see an R. So now I have S plus 7 times 3 equals 27. So 7 times 3 is 21. Now to get S by itself, I need to subtract 21 from both sides. 27 minus 21 is 6. So my R is 3 and my S is 6. And it is really important to note that they're telling us that we need to give it as R then S. Normally, when it's XY, we always know, yeah, X comes first, XY, that's standard. But because we have these different variables, make sure you're doing it, you're presenting it as they're asking you with the R value first, because sure enough, there's an answer where the S value is first. They reversed it, 6, 3. No, we want the one that is 3, 6. Now, that is our answer, 3, 6. Now, I mentioned talking about how R equals 3 and how you can kind of jump ahead looking at the answers. What I mean by that is once you know R is 3 and you know R is supposed to go first, if you look over here, oh my goodness, whiteboard, calm down. Calm yourself. Okay, if I look over here at my answers, there's only 2 of them that have 3 as R. I've already narrowed it down to B and C before I do any of this math. I already know it's going to be B and C. So if you don't want to do the math that's over here, you absolutely, if you look at those answers and say, hey, it has to be B or C, you could take the 6 and the 27 and plug them in here for S and see which one works. That is another way you could approach this. It also works just fine. Yeah, but see, you can tell if you look at these answers, they are really counting on you mixing up because it's RS and not XY, because look what you've got. You have 2 pairs. You have 6, 3, 3, 6, 3, 27, 27, 3. Yeah, they're just really counting on students not keeping those straight because they are different, so please be careful in these kind of situations. Number 5, the table shows selected values from function f, x and f of x. Which of the following is the best description of the function f? When we say f of x, we're saying the output of this equation, the y value. Kind of like if I had f of x equals 3x plus 2, and I said, okay, what is f of negative 1? Well, what they're wanting me to do is plug in a -1 wherever there's an x, and then do that math and see what the answer is. And that would be what f of 1 is. So this chart over here is telling us that these 4 values of x, -1, 0, 1, and 2, were plugged into this unknown function, and these points came out. Do I have to figure out what this function is? Nope, I most certainly do not. All I have to do is either graph it or look at it and kind of visualize it in my head and see what sort of form, what shape these points are creating. So if I had, and I am not drawing this to scale, but so if I have, well, actually, let's make this a little straight. Let's make this a little straight so it's not just absolutely horrific. I can do that, right? Right? Okay. All right, so on the bottom, got my -1, 0, 1, 2. Now I'm going to kind of skip. This is like a little symbol that I've skipped some numbers. And then I'm going to have 16. Let's make this a little, I'll write it a little bit out here. 16, 17, 18, 19. And let's see what's happening here. So my first point is -1, 16. Okay, then I have 0, 17. Then I have 1, 18. It does not like when I write dots. Microsoft Whiteboard. 1, 18 and 2, 19. What is happening here? What is this? This is a line. This is just a straight line. It's going up 1 over 1, up 1 over 1, up 1 over 1. It is very clearly a straight line. Now, I don't know what else happens with this function. I mean, at this point, honestly, I could write an equation for this function, but, you know, I don't have to. I can just look at what I've drawn and go, this is a line. Now, which of the following is the best description of this? And here are our options: decreasing linear, increasing linear, decreasing exponential, increasing exponential. Right, so when we're talking decreasing and increasing, we're talking about what happens when we go from left to right, like how we read in English. So is it going up as we go from left to right? Then it's increasing. Is it going down as we're going from left to right? Then it's decreasing. So increasing going up, decreasing going down. And what's happening here? If I'm going from left to right, this line is going up. So this is increasing. So there's only 2 options that say increasing, B or D. Now I have to know, is this linear or is it exponential? Exponential is going to have a curve. Linear is going to be straight. Exponential is going to look something like this. It's like a little arc heading for the sky, or it's heading down. It's going to be one of these 4 right here. Like that, one of those 4. It is not going to be perfectly straight, ever. So we have something that's perfectly straight, so it's not exponential. It is linear. It is an increasing linear. B is my answer. Number 6, the graph of a system of linear equations is shown. The solution to the system is xy. What is the value of x? This is very similar to an earlier problem. I think it was problem number 1, where, you know, it's just asking, where do these 2 linear equations, where do they cross? What is the point of intersection for this system of equations? So we just need to be very careful and not make any mistakes in either identifying the point or in writing it in XY form, and then we're home free. So there's my point of intersection, and I can see that the x value there is 4, and the y value is 1. Now this, honestly, I hate the way this thing is written, because tell me, like, look at that 1 and look at that -1. Every time I was looking at this, I kept doing a double take. I'm like, -1 on top and bottom? It's just poorly drawn. I'm just saying it looks like a -1 on both. And I can see some students going, wait, why are there negatives up here? Yeah, shame on you, SAT. I don't think that was cool. But fortunately, they don't want to know the y value. So that's, you know, we're not tripping up any students with that. They're just wanting to know the x, and that x is very clearly 4 for that that solution to that system of equations. It is 4, 1. So the value of x, the only thing they really want, is 4. Number 7, 23, 27, 27, 32, 35, 36, 52. What is the range of these 7 scores shown? The 4 things that you will need to know on the SAT are mean, median, mode, and range. They ask all 4 of those, and they do it interchangeably. Okay, so the mean is the same as the average. That's where we add everything together, then we count how many numbers there are, and we divide by how many numbers there are. So in this case, we would add all these up and then go, okay, 1, 2, 3, 4, 5, 6, 7. We would divide by 7. That is mean or average. The mode is what is the most common number, which one is repeated the most. That would be 27. The median is the number that's smack dab in the middle physically. So here there are 7 numbers. So this number 32 is smack dab in the middle. Physically, that would be the median. If you had an even number of them, then you would average an even number of data, an even number of numbers. You would average the 2 in the middle. And last but not least, range is where you see how far apart the first and last number are. The one sort of trick thing with range is sometimes I've seen where they don't put the numbers in order. So always check that first. Check that they're in order, and they are. They are from smallest to largest. So I have my smallest number 23, my largest number 52. And so to find the range, I would just subtract 23 from 52, 52 minus 23, and that is going to be 29. So the range of these is 29. But make sure you know all of those. Mean, median, mode, and range. They are going to show up. Right, number 8, note figure is not drawn to scale. In the figure, line M is parallel to line N and line K intersects both lines. Which of the following statements is true? Let's zoom in a little bit. The value of x is less than 145. The value of x is greater than 145. The value of x is equal to 145. The value of x cannot be determined. Okay, when things are not drawn to scale, we cannot rely on what we see. So we can't say, well, they look like they're the same, or they look like it's bigger or smaller. No, we have to go with the facts. And what are the facts? We are told that line M is parallel to line N. Put this a little bit in the center here. Okay, so line M and line N are parallel. And line K intersects both lines. So what we have here is a set of parallel lines crossed by a transversal. And there are a whole bunch of theorems and postulates and things that you have to learn in geometry when you're doing proofs and stuff with parallel lines and transversals. But the SAT, you don't have to say why you know something is true. You just have to know it's true. So here's what you need to know for the SAT. If you have 2 parallel lines and they are crossed by a transversal, then let's put these in orange. All of these angles are the same. And let's go in blue. These blue, these are the same. That's what you have to know. And in this case, any orange and any blue are supplementary. That is, they add up to 180 degrees. Again, there's a whole bunch of ways that you can prove this. I'll put links in the description below if you're wanting to know the reason why this is true, or if for your geometry class you're needing to know all those theorems and postulates about same side, interior angles, opposite side, corresponding angles, all that good stuff. But this basic chart, if you memorize this should take you through the SAT questions. So here, what do we have in this drawing? We have X and we have 145 degrees, and they're talking about these 2 angles right here. They are vertical angles or opposite angles, depending on what your math book says. And also, according to our little chart, they're the same. They are congruent. And this will always be true if we have 2 parallel lines and a transversal. These highlighted angles are going to be the same. That's it. That's the knowledge they're testing. We don't have to do any math. We just have to have this knowledge locked in our brains. So they're the same. Let's look and see which option here says that. Oh, that is option C. The value of X is equal to 145. That's my answer. It is C. Number 9, the equation x plus y equals 1,440 represents the number of minutes of daylight between sunrise and sunset. X, okay, I'm going to start writing this down. So we have x plus y equals 1,440. Okay, so x is minutes of daylight. Okay. And the number of minutes of non-daylight, y. Okay, so y is non-daylight. On a particular day in Oak Park, Illinois, if this day has 670 minutes of daylight, how many minutes of non-daylight does it have? All right, so 670 minutes of daylight. We're told x is minutes of daylight, so I need to replace x with 670. And then my question that I'm being asked is, how many minutes of non-daylight does it have? My y is non-daylight, so they're saying solve for y. Okay, let me erase all this so I can really just look at this problem. 670 plus y equals 1440, and I need to solve for y. So I need to undo what's been done to y. I need to undo this addition of 670, so I need to subtract 670 from both sides. And if I do that, I will get that y is equal to 770. And looking over here at my options, there it is. There is B, 770 minutes of non-daylight. That is my answer. Number 10. Scott selected 20 employees at random from all 400 companies at 400 employees, at a company. Okay, so he has 400 employees and he pulled out 20 at random. He found that 16 of the employees in this sample, 20 is my sample. Okay, so 16 are enrolled in exactly 3 professional development courses. Okay, so 16 of them are in 3 courses this year. All right. Based on Scott's findings, which of the following is the best estimate of the number of employees at the company who are enrolled in exactly 3 professional development courses this year? So they're asking us to use a sample to predict the whole number. So 16 out of 20 are in 3 courses. And if we assume that this ratio holds true for the whole company, we'll say, okay, then how many out of 400 can we expect? So this is our total number of the sample. Here's our total number of employees. On top, we have total number in the sample that are in 3 courses. Over here, we would have total number of employees in the whole company that are in 3 courses. Now, I can solve it just as is. If you're doing this on your calculator, it's equally easy either way. Cross multiplying is a great way to do it. So I'd cross multiply those and get 20x equals 16 times 400. If you're wanting to do this manually, you can simplify this fraction on the left, like if you're not wanting to use your calculator, and it might make it a little easier. So 1620 simplifies down to 4/5. Go on, there we go. To 4/5, and that may be a little bit easier, again, if you're doing this by hand and not wanting to break out the calculator. So same thing, we would cross multiply. 5 times x is 5x, and 4 times 400 is 1600. Then we would divide both sides by 5 to undo that 5 times x, and we are going to get 320. Another way you can look at this is if you were at this point and it's 4/5 and it's 400, you might say, what is 4/5 of 400? Well, what is 1/5 of 400? 400 divided by 5 is 80, and then 80 times 4 is 320. Another way you could look at it. That's one of those things. A lot of these problems, there is not one set way to solve them. So I would say the skills here that are absolutely necessary for the SAT would be the skill of creating a proportion and being able to cross multiply and solve, and also the skill of recognizing how a sample can predict the whole. And that will get you to your answer of 320B. Number 11, if 4x minus 28 equals negative 24, what is the value of x minus 7? Two ways you can do this. Well, actually three. You could graph it too. I wouldn't recommend graphing. I think it takes too long on this one. But anyway, you can graph it. I would just say if you were to graph it, you would put this in your graphing calculator to solve for x and then plug that into x minus 7. I don't recommend that. Anyway, you can though. Moving on. Two ways you can do this. The first way is you can solve, there we go, 4x minus 28 equals negative 24. You can solve for x right here and then plug it into x minus 7. There actually is a way that's even shorter. I'll show you that in just a second. So to solve this, using what we have here, we want to undo what's been done to x. First, I want to undo this minus 28 by adding 28 to both sides. And I get that 4x is equal to a positive 4. Negative 24 plus 28 is positive 4. Then I'm going to divide both sides by 4. Since 4 times x, we want to undo that to divide by 4 to get rid of that. So I divide on the left and I just get x, and on the right 4 divided by 4 is 1. So if x is 1, what is the value of x minus 7? Well, 1 minus 7 is equal to negative 6, and that's C. That is my answer. There is a shortcut. A lot of times with these, when it's, always look for this, because it's, if what I'm about to tell you makes sense to you, then keep this shortcut in mind. Anytime they ask you for something that's a little odd, like here it's x minus 7. What's the value of x minus 7? That's not usual. Usually they'll say, what is the value of x, right? They won't say x minus 7. Anytime it's something odd like that, like x minus 7, I always look at my original, let me make that a little smaller. There we go. Equation. And I see, is there a way I could manipulate it to make it turn into the x minus 7? So, okay, 4x minus 28 equals negative 24. X minus 7. I go, wait a minute. 4x minus 28. If I multiply x minus 7 by 4, I would get there. So what if I divide everything by 4? Okay, just do that. Divide everything by 4. And what do I get? On the left, I get x minus 7, and on the right, negative 24 divided by 4 is negative 6. So the value of x minus 7 is negative 6. Again, if that style of thinking, if that just made sense to you, and you go, okay, I can see that, then log this away. And anytime there's an unusual thing that they're asking for the value of, look for this first. 9 times out of 10, this is what they're doing. And they've incorporated a little shortcut. Again, if that doesn't make any sense at all, just, solve for x and then get the value of x minus 7. Perfectly fine. Great way to solve this problem. You do what works best for you. Number 12. For a snowstorm in a certain town, the minimum rate of snowfall recorded was 0.6 inches per hour. Okay, I'm going to write that down here. The minimum is, I put miximum. Minimum and maximum. Miximum. The minimum is 0.6 inches per hour. There we go. And the maximum is 1.8 inches per hour. Okay, so I know at all times it was somewhere in between here. It's between this minimum and maximum. Those are the boundaries. Which inequality is true for all values of S, where S represents a rate of snowfall in inches per hour recorded for this snowstorm? So at any point in time, S is my inches per hour. I know it has to be between these two. So it has to be greater than or equal to 0.6, because the 0.6 is the minimum. It could be that. And it has to be less than or equal to 1.8. It has to be somewhere in that range. Now I'm going to look over at my answers and see if any of those match. Yep, sure enough. D, 0.6 is less than or equal to S is less than or equal to 1.8. That's it. Just be extra careful. When you're reading these longer problems, they're counting on you making a mistake and in your reading comprehension. So, take a beat, read it carefully, and you'll get the right answer. 13, y equals 4x and y equals x squared minus 12. A solution to the given system of equations is x and y where x is greater than 0. What is the value of x? When they say this where x is greater than 0, that's a clue that there's more than one solution. And even just this term here at the beginning, a solution to the given system of equations. This implies there's another besides this one. This is one solution. But we want the one x is greater than 0, or in other words, x is positive. What is the value of x? Okay, so y equals 4x and y equals x squared minus 12. You can absolutely do this as a graphing. You can plug this into your graphing calculator, and you're going to get x squared minus 12. That is a parabola. That's going to be a vertex down here at negative 12. And then y equals 4x. That is going to be a line that's going to go through the origin. It's going to be pretty steep. It's going to have a very steep slope. And you're going to see the two places where they cross. That is absolutely a viable way to do this. All right, here's the other way. Here's the mathematical way. We say that y is equal to 4x and y is also equal to x squared minus 12. Since they're both equal to y, we can set them equal to each other. Another way of looking at it is saying if y is 4x, we can substitute 4x for y. You will get the same, whichever way you look at it there, you're going to get the same thing of 4x is equal to x squared minus 12. This is a quadratic. To solve it, I need it to be equal to 0, so I need this 4x to go over there. So I'm going to subtract 4x from both sides. And I'm going to put it over here on the left a little bit. 0 is equal to x squared minus 4x minus 12. Now this will factor easily. You can also solve it using your quadratic formula. You also could graph this, honestly, and see where this parabola crosses. You do it as y equals all this to graph it and see where it crosses the x-axis. Or you could just put it in like this and it will give you two vertical lines. Yeah, you can do that if you want to graph it. I like factoring, so I would choose to factor it because I like it and I'm pretty fast at it. So I'm looking for two numbers that are going to multiply to get a negative 12, but that will add to get a negative 4. So what multiplies to 12? And I'm going to just write them as positives. 1 and 12, 3 and 4, 2 and 6. Which of these is 4 apart from each other? Because when it's a negative, that's what we want. We want ones that are this many apart from each other, and that will get us the right answer. 2 and 6 are 4 apart. Okay, so which one of these, 2 or 6, should I make negative so they add to a negative 4? That is going to be the 6. If I had a negative 6 and a positive 2, I will get to that negative 4. Side note, if you need to write all these out as like negative, come here, pen. There we go. Negative 1, positive 12, 1, negative 12, positive 3, negative 4, negative 3, positive 4, etc. Absolutely, write them all out. Totally fine. Up to you. So 2 and negative 6 are going to be my two numbers. So I know that this factors into x plus 2 and x minus 6 equals 0. And then I'm going to set each of those separately equal to 0. X plus 2 equals 0 and x minus 6 equals 0. When I solve for x here by the side I'm going to subtract 2 to both sides, I will get x equals negative 2. Here I'm going to add 6 to both sides. To undo that, I'm going to get x equals positive 6. Again, they wanted the solution where x is greater than 0. Only one of these applies, that is x equals 6. So what is the value of x? X is 6. 6 is my answer. Again, see me, I'm into factoring. I'm really fast at factoring. So if I were taking this test, my choice would be to factor. I can scribble it quickly and get my answer. Other students, graphing and then seeing where they intersect and picking the positive value of x is going to be the way to go. Choose what works best for you. Okay, let me get rid of these here. All right, number 14. Zoom in a bit here. A store sells 2 different sized containers of blueberries. The store's sales of those blueberries totaled $896.86 last month. $896.86 last month. Okay. The equation 4.51x plus 6.07y equals 896.86 represents the situation. Okay, I'm going to write it anytime I have these long, let's make this a little smaller. Anytime I have these long equations and these long, written problems, I always start making my own notes because I just want to keep track of all the information they're giving me. And a lot of times it's not that the math is that difficult or, what they want me to do is that difficult, but they're trying to trip you up. They're trying to make it so you're just like, oh, what? I don't know what's going on. Any notes that you need to take to get it sorted in your own head, draw pictures. If you want to draw pictures of the blueberry containers, go for it. Okay, so we're told X is the number of smaller containers sold. Okay, so X is the number of smaller containers sold, and Y is the number of larger containers sold. Okay? According to the equation, what is the price in dollars of each smaller container? So this is more just about us logically saying what's going on. All right, and I'm going to make my own equation. If I said, I'm not even going to look at this for a second. If I said I'm selling blueberries and I have a small and I have a large, and my small costs $2 and my large costs $3, and I sold 10 of the small and 20 of the large, how would I find out how much money I'd made? Well, I would say I would multiply that cost, $2, times the number of containers that I had sold, and I would add that to the cost of the larger times the number of containers I'd sold. And I would say, okay, so 2 times 10 is 20, 3 times 20 is 60, so together I sold $80 worth. And what was in this equation? What did I have here? Here I had the number of the smaller containers. Here I had the number of the larger containers. Here I had the price of the smaller containers. And here I had the price of the larger containers. And here was my total. Okay, so it looks like I've created an equation that is very much, erase that over there, very much like this other equation. It's okay, I'm going to put here, this was the total. All right, so if I want to know, what they're asking is, what is the price of each smaller container? Well, in my equation down here, it was this number that was being multiplied by the number of smaller containers. So if I look up here, the corresponding, that would be 4.51 is being multiplied by the number of smaller containers. So $4.51. That's going to be it. That's, and so again, this right here, this kind of thing, don't be afraid to write out something with numbers that are a little more straightforward so you can really get a grasp on these ones where they put these things with multiple decimal points and stuff trying to trip you up. Anything that you can do, any tool you can use so that you can better understand a question, that's a good one. Number 15. A right circular cylinder has a base diameter of 22 centimeters and a height of 6 centimeters. What is the volume in cubic centimeters of the cylinder? Okay, so I always start by drawing things. So we have our right circular cylinder. So we have these vertical sides that are forming a right angle to the base. If I draw a straight line down, it's going to form this nice right angle. Okay, so that's what that means. And we are given the dimensions here that the base diameter, note that is diameter, not radius, is 22 centimeters. And we're also told that the height is 6 centimeters. Okay, what is the volume in cubic centimeters of the cylinder? Now, this formula for volume of a cylinder is provided to you by the College Board. So if you forget it or you're having a blank, like, oh, I'm not 100% sure, was it this or this? By all means, use that reference. Don't guess if you can't remember. That being said, this is a good thing to try to memorize beforehand, because the more things that you can very quickly recall and you don't have to spend that extra time looking at the reference, it's going to save you, I know it's just seconds here and there, but it does add up. It just does. So if you can memorize these formulas, it is helpful. But again, of course, if you're having any doubts, if you have the formula correct in your head, please use that reference and be sure. Now for cylinders, cylinders are in the prism family. So it falls into things like triangular prisms that look like that, kind of, and rectangular prisms. Wow, that's a really bad start to a rectangular prism. Okay, there's a rectangular prism like that. The formula for all of these follows the same principle, and that is going to be you find the area of the base and you multiply by the height for all of these. Now, the specific formulas, like the cylinder specific formula, will look a little bit different because they're going to replace that B with the formula for area of the circle, because the circular base, so that is pi r squared. For the triangular prism, the area of that base is going to be 1/2 base times height of that triangle, and then you multiply by the height of the prism. And same with this rectangular prism, they're going to go length times width times height. Well, length times width is the area of the base times the height. So whichever makes it easier for you, if you want to learn those three individual formulas, you know, the pi r squared times height, the area of the triangle, which is 1/2 base height times the height of the prism, or length times width times height, or if you just prefer to memorize this area of the base times height, again, whatever makes it easiest, whatever makes it so you can recall it to mind the most easily and the most quickly. Okay, so here we have area of this base times its height, or pi r squared times its height. And again, note that they gave you diameter. That's very critical. I guarantee you there will be students that do not realize that it was diameter and they were just going to plug that 22 in for the radius. Please do not be sucked in by that little trap. They love to trick the students. Okay, so if the diameter is 22 centimeters, the radius is going to be half of that. So 22 divided by 2 is just 11. And then I'm going to plug my numbers because I have my radius, I have my height of the cylinder, so I'm ready to go. So pi times the radius, which is 11, squared, times my height of 6. Okay, so let me zoom out a little bit. I always run out of room because I write too big. And then so I'm going to bring this down here. So again is pi, 11 squared is 121 times 6. And I wrote 12 because I'm getting ahead of myself. 121 times 6. 121 times 6 is 726. And that pi just comes along for the ride. And if we were writing this like on a test or on our math homework, we would write centimeters cubed after it. Always don't forget those units. They are eliminating that here because they're asking us what is the volume in cubic centimeters, so we don't have to include that. You're like, why are cubic centimeters not there? Because they're up there. All right, so 726 pi, and that is C. And yep, sure enough, look at that option D. That would be if I used 22 and I squared 22 and then multiplied it by 6. I would have gotten D. So yeah, they are absolutely counting on you to do that. Always, always, always double check and make sure that you know what you've been given, in this case diameter instead of radius. And C, 726 pi is your answer. Number 16. This one takes up like the whole page if you're looking at the paper version of this test, the digital version. The graph, actually I'm going to zoom in because let's make it so you can actually read it. How about that? The graph of the rational function f is shown where y equals f of x and x is greater than or equal to 0. Which of the following is the graph of f of x plus 5 where x is greater than or equal to 0? Okay. This type of problem where they're taking a function and they are translating it, they're moving it around the xy plane, very, 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 very common on the SAT. They love it. All right, so I always like to go through the basic rules when one of these problems shows up because I think these rules are worth learning. Just, it happens all the time, and if you can learn these rules, man, it's going to save you so much time so that you're not trying to plug things into Desmos to figure these out. They're a lot quicker if you know these rules. Okay, so here's the basic, and this is going to apply, to all of our functions. So like, let's say if I had y equals x squared, we can also call this, I'm going to, f of x equals x squared, right? That's what it looks like, essentially. It's just a parabola. It has a vertex at 0, 0, and that's it. What would happen if I said plus 2 on the outside? If you were adding something outside of that core original function, it's going to move it up or down on the y-axis, and it's going to move it directly. So if it says plus 2, it's going to move it up 2, and you're going to end up with the same parabola, just up 2. Okay, what if that change happened inside of this core function and it was plus 2 in here? Well, if it's inside it, like inside those parentheses, it's going to move it left or right on the x-axis, but it's going to move it in the opposite of what you're seeing. So plus 2, it's going to move it towards the negative 2 on the x-axis. So it moves it that way. The other common things that you see, the moving up and down is what they love the most inside the SAT. But the other common things that you will see is, let's say if you have the x squared and you put a negative in front of it, that flips it upside down. And then the other one you'll see, the last one you'll see for these kind of problems is if there is a number in front of it. They put a number in front of it. If that number is greater than 1, it's going to make this, oh, I messed up my pattern. Green, there we go. If it's greater than 1, it's going to make it narrower. It's going to compress it laterally. And if it is a positive number but less than 1, so a fraction, like say 1/2, that's going to make it wider. It's going to stretch it. Now all of these can be combined, and they like doing that as well. So if I had this original x squared, and let's say I added on a -1, a plus 2, and a negative out front. Okay, so the vertex is going to move it. This -1 is going to move it to the right 1. It's going to move it positive 1 on the x. And this plus 2 is going to move it directly. It's going to move it plus 2 up. So my new vertex is going to be right there. And I don't have a number out front, so it doesn't get wider or narrower, but I do have a negative, so it's going to flip it. And it's going to look kind of sort of something like that. So these rules, these basic rules, it's worth practicing these. It's worth remembering them. It comes up all the time. So here you say, well, this looks a little bit different because it's not that we had, like x squared and then we added 5. It was y equals f of x, and then it's y equals f of x plus 5. Well, since y equals f of x, so whatever this is, whatever this thing is the whole function, we can treat it the same way because it's the whole function and then 5 is being added on the outside. Remember I said when we had that whole function in the example of x squared and then 5 is added on the outside, it's the same. So if I just said x squared plus 5, or I said f of x, and I already told you that f of x is x squared plus 5, it's the same thing. I'm hoping I explained that correctly and in a way that's easy to understand. But because it's a unit, this whole thing is a unit, and so that plus 5 is being added on the outside. And so here you have that f of x is the whole unit, and the plus 5 is being added on the outside. So it is outside of the function, and we can treat it as it's moving it up and down on the y-axis. Okay, so how can I tell which of these is that top one moved up or down on the y-axis? Now you might look at it and go, well, clearly this one is moving up. Oh, this one looks like it's moved down. This one really looks like it's moved down. This one just looks a little flatter than that one, or didn't really changed a little bit, but not a lot. This one clearly looks like it's moving up and down. And, frankly, you are right. That is our answer right there. It has moved up. But for your future reference, the way you do this to be sure, like if it's not perfectly clear, you're going to pick a test point. A point that is visible on here and looks like it's going through a point of intersection. So I might go for that one right there. And actually I'm going to go, boom, And boom, there's my 2 test points that look pretty clearly like they're going through a point of intersection. So the first one there would be this. I have picked a wrong. Let's make this a little smaller so you can actually see this. Hey, there we go. That first one is 3, 3. And that second point is 9, 1. So if this point 3, 3 was to go up by 5, that x is going to stay the same. X doesn't change. The y value will go up by 5. So I would expect it to go up to 3, 8. 3 plus 5 being 8. Same with this other one, 9 and 1. That 9 is not going to change, but the 1, that y value will go up by 5. So 9, 6. And then you're going to look for one of these points. And if you find 2 graphs that have one of those points, then you look for the other point. Okay, so here's my first one, 3, 8 and 9, 6. Not even close. There's 3, 8 and there's 9, 6. Nope. My second one, there's 3, 8 and there's 9, 6. Not a chance. My third one, there's 3, 8 and there is 9, 6. And my last one, there is 3, 8 and doesn't like when I draw dots. Never does. Okay, there we go. And there is 9, 6. So yes, that is confirming that it's D. Again, with something like this where like your choices A, B, and C are clearly not moving up and we know it needs to move up, you don't necessarily have to go through this process. This is a way of confirming it if you are unsure or if you have a couple of graphs that look similar. Again, I'm giving you techniques that will help you not just for this problem, but for any problems that you may have that are using these similar topics. Okay, so again, our answer for that one is D because it moved up 5. 17. At a particular track meet, the ratio of coaches to athletes is 1 to 26. Okay, so coaches... go. Coaches to athletes is 1 to 26. If there are X coaches at the track, which of the following expressions represents the number of athletes? Okay, so there are X coaches, then how many athletes? Right, so because I set up this little proportion up here, I can cross multiply and get another statement that is also true. That's how this works. I love cross multiplying. It is lovely. Helps us so many times in these problems. So if coaches to athletes is 1 to 26, then I can cross multiply and I can say it's also true that 26 times the number of coaches equals athletes times 1, or just athletes. C times 26 equals A times 1. So 26 times the number of coaches equals the number of athletes. Well, now we're saying there are X number of coaches. How many athletes? So I can plug in X for my number of coaches. So 26 times X will equal the number of athletes at that track meet. So 26X. And we look over at our choices. There it is, B. It is 26X. That's it. Another way that you can do this, if this sort of representational thinking doesn't make as much sense to you, you can also just use real numbers. Real numbers are fine. Absolutely fine. Again, the SAT, it's not like in a math class. And some students have a hard time getting past this. In a math class, if you are studying a particular topic and your teacher is saying like, factor this using the quadratic formula, and if you decide to factor it using regular factoring or find the solution via graphing, you're going to get it wrong. Because you're like, you didn't use a quadratic formula. That does not apply here. The SAT does not care. If you're using your own brain, you're not cheating. It doesn't care how you get the answer. So you don't have to use algebra in this case if you didn't want to. It's totally up to you. It's your choice. It's your test. Do it. Take it how you want to. Figure it out how you want to. So if you said coaches to athletes, all right, it's 1 to 26. All right, so for every one coach, there's 26 athletes. So you can just start plugging numbers in if you want to. Totally fine. So you can say, okay, so if there's one coach, there would be 26 because it's 1 to 26. All right, so if there's 2 coaches, then there would have to be 52 athletes. Because for every 52 athletes, then there would be 2 coaches. Okay, then for 3, then there'd be 78. And you go, okay, which of these is, well, that was an awful little, there we go, isn't that prettier? Which of these represents what I'm doing over here? X divided by 26? No, that's not what's happening. 26 times the number of coaches? Yeah, it looks right. 1 times 26, 2 times 26, 3 times 26. X plus 26? Nope. 26 divided by X? Nope. B is correct. So yeah, you can do that. You can plug stuff in. Absolutely fine. And either way, you're going to get the answer of B, 26X. Kaylani used fabric measuring 5 yards in length to make each suit for a men's choir. Okay, so Kaylani is making little suits. That's an awful suit. And each one uses 5 yards. Okay. The relationship between the number of suits that Kaylani made, X. Okay, X is number of suits. Okay. The total length of fabric that she purchased, Y. Okay. This is yards of fabric purchased. Okay, we're getting a lot of variables, a lot of information thrown at us in yards, is represented by the equation y minus 5x equals 6. Okay, what is the best interpretation of 6 in this context? Well, let's fill this in. So we have y is yards of fabric purchased. So actually I'm going to type this over here because this seems yards of fabric. Okay, so we have yards of fabric purchased. Let's move that over here. Okay, and so that is going to be, we're going to subtract 5 times, and this is going to be number of suits. Okay, and that equals 6. Okay, and so now they're saying, what does 6 mean? Well, let's look at our little equation we just wrote. So Kaylani went and she bought a whole mess of fabric at the fabric store. And then 5 times the number of suits. Well, where's that 5 coming? We're told that there's 5 yards for every suit. Okay, so if there's 5 yards per suit and I'm multiplying 5 times the number of suits, then what does that mean? That is telling me how much total yardage, if that's a word, she used. So if she had made 10 suits, then she would have used 5 yards times 10 suits, 5 times 10, or 50 yards. If she made 11, she made, 50 suits, because she's just a lean, mean suit-making machine. If she made 50 suits, then it would be 5 times 50. 5 yards times 50 suits, 250 yards. So if we had the original number of yards that she bought minus the number of yards she used, then what is 6? 6 is how many yards she has left. So let's look at our options over here, our choices, and see which of those best matches what we've determined here. That 6 means the number of yards she has left because she has the yards of fabric she bought minus the yards of fabric she used. 6 would be yards of fabric she has left. A, Kaylani made 6 suits. No, 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 no. B, Kaylani purchased a total of 6 yards of fabric. No. Not even a little bit. She'll only make 1 suit. Kaylani used a total of 6 yards of fabric to make the suits. Nope, because we know it was 5 per suit. 5 does not go into 6 evenly. And finally, D, Kaylani purchased 6 yards more fabric than she used to make the suits. That's a different way than we phrased it, but it means the same thing. She had 6 yards left over, so she purchased 6 more than she needed. And that is our answer, D. Number 19, what is the value of tangent of 92 pi over 3? You absolutely can, try to use your calculator to do this. Couple of things to note. If you'll notice, first in these answers, every single one has a square root in it. So if your your calculator gives you the answer with the radical with that square root in it, it'll make your job easier. If they give it to you as a decimal, as an irrational repeating number, you have to make sure that you're able to convert it to one of these. Also, please, please, please note that this 92 pi over 3, that is in radians. It is not in degrees. We do not have our little, degree sign there. So it's in radians. Now, if you look at the answer key to this, it's going to tell you to use the unit circle. And you know, so it's up to you if you want to use your calculator and deal with the radicals and see if your I keep saying computer, if your calculator will give you the answer with the radical, and make sure that you have it in radians. Absolutely, because if your calculator is set to degrees and you type in what is the tangent of 92 pi over 3, it's going to just keep doing it in degrees. It's not going to assume that you meant that's radians. Now, if you want to convert it to degrees, you can do that if you don't know how to change the setting on your calculator. To convert this to degrees, you multiply it by 180 over pi. And if you're going the other way, if you're going from degrees to radians, you multiply by pi over 180. The way that I remember this is, you know, if there isn't a pi in the original, you're trying to add a pi. If there is a pi in the original, you're trying to get a pi's to cancel out. That always helped me, as remembering if it's 180 over pi or pi over 180. So in here, I'm starting with the pi. I want the pi's to cancel out, so the pi needs to be on the bottom so those can cancel out when I'm multiplying. That's my little personal mnemonic. So when you do this, when you multiply these together, you know, the pi's are going to cancel. You can do 3 goes into 180 60 times. It goes into 3 one time. And when you multiply, you're going to get 5,520 degrees. And you can put that into your calculator and say, what's the tangent of that? Again, if it doesn't do radicals, you're going to have to convert it to try to figure out which one of those it is. Your other alternative for this, outside of using a calculator, is to use the unit circle. And so here is a unit circle up here. Now, they do not provide this for you. You have to have this in your head. Now, some math teachers will make you learn this for math class. If you have learned this, okay. I don't know that I would really recommend it to memorize it if you haven't memorized it already. It doesn't show up that often. It's up to you. It can save you a little time if you know it. That's going to be up to you. If you're saying, I might have a question that asks for my knowledge of a unit circle. It doesn't show up as often as a lot of the other concepts we're going over. All right, so 92 pi over 3. Did I copy that down correctly? Yes, I did. All right, so this is a huge number. And you're not going to be expected, because like as we said, 5,520 degrees. Like, oh my goodness, how do I find this using this little unit circle? And I should say first, before we get into this, the unit circle is a way of showing the sort of standard sine, cosine, and tangent of our most standard angles. So you have 0, 30, 45, 60, 90, 120, 135. So it's every 30 degrees, every 90 degrees, and also every 45 degrees. So all those together, those show up a lot. Now, when you look at the coordinates, this is a circle with a radius of 1, and it goes all the way around. Each coordinate at a point is x and y. The x value is your cosine. The y value is your sine. And to find tangent, you're going to put sine over cosine. Okay, so let's look at what this means for like 30 degrees right here. If we look at my x and y coordinates there, those coordinates mean that sine is the y value, and that's 1/2. The cosine of 30 degrees, or pi over 6 if we're using radians, is going to be square root of 3 over 2. And the tangent is going to be sine over cosine. And you see I have the two fractions, top and bottom, but they both have the same denominator. When that happens, you can essentially, they cancel. They cancel. Because what you'd be doing is you would multiply the top and the bottom both by 2. I feel the need to show you this, right? So you can see what I'm telling you is the truth. 1/2 over square root of 3 over 2. You're going to multiply by 2 over 2 because that is 1. 2 over 2 is 1. So when I multiply 1/2 by 2, I get 1. When I multiply square root of 3 over 2 times 2, I get square root of 3. 1 over square root of 3. So it is like the 2's cancel out, essentially. A little shortcut way of seeing it. So the tangent then will be 1 over square root of 3. And that is how the unit circle is used to find the sine, cosine, and tangent, to help memorize the sine, cosine, and tangent for all of these common angles. Okay, random ruler out of nowhere. Right, so back to our 92 pi over 3. Well, where does that come in? Where is 92 pi over 3 on this? Okay, so if you were to go all the way around the unit circle, that's 2 pi. Go around it again, 4 pi. Go around again, 6 pi. Go around 8 pi. So we can remove multiples of 2 pi from this. Well, what is this? If we convert it, I'm going to convert it to a mixed number. So 92 pi over 3. 3 goes into 92 30 times with a remainder of 2. So this is 30 and 2/3 pi. Okay? So 30 pi, and we have 30 and 2/3 pi. So this would be the same as 30 pi plus 2/3 pi. And 30 pi is divisible by 2 pi. That would be going around 15 times. Okay, so 15 circles go around. Okay, gone around 15 times. That's our 30 pi. It's going around 15 times, and then it goes around 2/3 pi. And that should be more like 2/3 pi. There we go. Because you start here, it goes around, that's 2 pi, 4 pi, 6, 8, 10, 12, 14, all the way up to 30 pi, and then it goes another 2/3 pi. So how far is 2/3 pi? It is right here. It is 120 degrees. So it's the same as the tangent of 120 degrees or the tangent of 2/3 pi. And again, how do we find tangent when we have this right here? It is sine over cosine. That sine is the y, so that's square root of 3 over 2. And my cosine is my x, negative 1 over 2. So that is going to be, let's erase this so I have some room. Remember, those 2's just kind of vanish, and we're left with square root of 3 over negative 1, which would be the same as negative square root of 3. Now let's go down and look here, and sure enough, a negative square root of 3 is right there. That is my answer. And again, if you know the unit circle and you're able to kind of like, oh yeah, I remember like 120 is this, then you could do that, that way. If you were able to figure out that's 120 degrees or 2/3 pi, and you could actually draw it out and go like, okay, well that's a triangle then. If that was my unit circle, if that's 1, you can do that. You can do however you want. This isn't one where I'm going to like sort of say, oh, absolutely the unit circle is faster, or absolutely using the calculator is faster. It's going to be up to you. It just is. This, again, unit circle doesn't come up that often. I feel like this explanation was a little bit meandering. I'm sorry about that. But yeah, things to look out for if you're using your calculator. Make sure that your calculator is set to radians, not degrees. Make sure that if you're having to convert from an irrational decimal into a square root, that you do it correctly. If your calculator gives you the square root, I mean, hey, you're flying high. That's pretty, nice and straightforward. But yeah, if you look at the answer key, they're going to tell you to use the unit circle. So up to you. Number 20. Note the figure is not drawn to scale. In the triangle shown, what is the value of the cosine of x? They don't want you, whenever they say not drawn to scale, they're not wanting you to go, okay, so if I measure this part with a piece of paper and kind of fold it over here, and then I'll figure out how long this side is. No, they don't want you to do that, which you can, I think, tell this is not drawn to scale, because 11 is less than half of 28. But if you were to draw a line that same length, right there, you're like, whoa, that's more than half of that 28. So you can tell this is not drawn to scale. Now, cosine of x. What is cosine? How do we get cosine? Well, our little abbreviation that you will see over and over and over again is to help us remember that sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH, and tangent is opposite over adjacent. And what do we mean when we're saying opposite, adjacent, and hypotenuse? These are all talking about right triangles, and it's talking about the lengths of sides and how they're related to the angle in question. So here it's x. x degrees. This angle up here, x. If I'm looking at x, what is my opposite side? It's the one across the table from x. It's like if I'm sitting here at a table and I'm looking who is sitting opposite me, they're over here. Who is sitting adjacent to me? They're next to me. They're right here. Same thing with these triangles. So here, the opposite side would be over here, the one it's looking at, and the adjacent side is the one sitting right next to it, right? They're bumping elbows at the dinner table. And the hypotenuse, which is used in both our sine and our cosine, is always going to be our longest side, and it's always going to be the one opposite the right angle. So for this, to find the cosine of this angle, cosine is adjacent over hypotenuse, so I need to have the length of the adjacent side, which is this one. I need to have the length of the the hypotenuse. Length of the hypotenuse, which is this one. And they've given it to us. I don't have to use Pythagorean theorem to figure out the length of this side. If it were sine or tangent, I would, because both of them require the length of the opposite side. But no, they've given it to us. They've given us the adjacent side. They've given us the hypotenuse. So the adjacent side is 11. Cosine says over hypotenuse, which is 28. 11 over 28. That's it. I almost think this one is tricky because it's simpler, especially coming off of that unit circle one. I think they're trying to suck students in and go like, you need to use Pythagorean theorem to figure out this side. And you don't. It's just 11 over 28. That's your answer. 21. The function g is defined by g of x equals x plus 14 times t minus x, where t is a constant or a number. In the xy plane, the graph of y equals g of x passes through the point 24, 0. What is the value of g of 0? Okay, so we don't know what t is. We just know it's a number. We know it's a number. And we know that 24, 0 makes this a true statement. Okay, so x plus 14 times t minus x equals g of x. Okay, and I know that y equals g of x, or just saying if this were y equals g of x, passes through the point 24, 0. So I can plug in 24 for x and 0 for y, and then I will be able to solve for t. And then we'll move on to what's the value of g of 0. But first I have to know what t is. So if x is 24, I'm going to put 24 in both of those. And I know that that equals 0. Okay, now at this point, there's two ways you can look at this. You absolutely can add this and then distribute it through there and then solve for t to get 0. But there's a shortcut. There's a little shortcut that I'm going to show you. And I will show you in a minute how it would work if you did all this math. But here's the shortcut. I have two numbers that are being multiplied together. 24 plus 14 together is a number, and t minus 24 together is a number. And together, they're being multiplied and together, and they get 0. So you know how like when we're doing factoring, and you factored a quadratic, and you get to like x minus 2 times x minus 1 equals 0, and then to solve, you set them both equal to 0 separately, because either one of them could be 0, but you know one of them has got to be 0 to multiply together and get 0. Same principle right here. Now look, I know 24 plus 14 is not 0. You know, even if I'm looking at that, and even if I don't do that math in my head, I know that's not 0, right? You know it's more than 0. So t minus 24 must be 0, right? And if t minus 24 is 0, what is t? If we add 24 to both sides, we can solve and say t is 24. It's like, okay, all right, that's it. So I'm going to write this up here, that t is 24. Now I'm going to back up a little step and say what would have happened if I had not had that realization and if I had just done this math, which is totally fine, by the way. Just because you don't have that little, moment of epiphany doesn't mean you're going to get the wrong answer. All right, so 24 plus 14 is 38. We have this times t minus 24, and I need to distribute that. So I get 38t minus, and I can multiply a lot of stuff in my head, but 38 times negative 24? No, I cannot multiply that in my head. And that is 912. And that is going to equal 0. And so then, as I zoom out a little bit and I move it up, I'm going to add 912 to undo that. I'm trying to get t by itself. So, it's being multiplied by 38 and then negative, 912 is being subtracted. So I'm undoing that. So I add 912 to both sides. And I am going to get 38t on the left and 912 on the right. So now t is being multiplied by 38. To undo that, I do the opposite of dividing by 38. And lo and behold, I still get that t is equal to 24. So, it takes a little bit longer, but it still gets you the right answer. And at the end of the day, that's the most important thing. Okay, so now we know t is 24. Go back up. So now I know that my full proper equation is x plus 14 times 24 minus x. So now they want to know the question is, what is the value of g of 0? We say g of 0, it's saying everywhere there's an x, plug in 0, do the math, see what comes out. That is, the value of g of 0. Okay, so I'm going to plug 0 in for x. So I have 0 plus 14 times 24 minus 0. 0 plus 14 is just 14. 24 minus 0 is 24. And let's see, 14 times 24 is 336. So that is it. That is my value of g of 0. It is 336, and that is my answer. Number 22. X plus 4 squared plus y minus 19 squared equals 121. The graph of the given equation is a circle in the xy plane. The point A, B lies on the circle. Which of the following is a possible value for A? Okay, now circles are one of those things that they look very fancy, but it's actually very straightforward as to what this equation that we have here means. This is the base form, standard form. X minus h squared plus y minus k squared equals r squared. H and k, that is your center of that circle. Notice this is the opposite, so this is a negative h or minus h, and we just want h. So it's subtracting that h, and then that's what goes there. So the way of thinking of that is the opposite of whatever's there, and then the opposite of whatever's here. That's going to be your center. And then this number that's by itself is the radius squared. So take the square root of that and you will have your radius. That's it. So once you have that memorized, this sort of problem, like right here, you wouldn't need to put it into Desmos or into a graphing calculator. Again, if you want to, like with all these, if you want to put it in a graphing calculator, if you are more comfortable doing that, if you're more confident in your answer, go for it. We want you to feel confident that you have the right answer. But for like this one, that's a lot to type in. X plus 4 squared plus y minus 19 squared. I think it can be done faster by hand. Your mileage may vary. So we're told the point AB lies on the circle. Which of the following is a possible value for A? Well, I need to know where this circle is. So I'm not using the graph in the background, just kind of sketching a quick for myself sort of sketch. So our first part, x plus 4. So I know the x coordinate is the opposite of positive 4. It is negative 4. And then y minus 19. So I know the y coordinate for the center of that circle is the opposite of that. It's positive 19. This is not to scale. Okay. And I also know that the radius, there we go, comes from here, 121. That is the radius squared. So if I take the square root of 121, I get 11. So I know this circle has a radius of 11. Now, so it's a circle and it has a radius of 11. Does it matter that I haven't drawn this very well at all? Not really. This is just for me to visualize so I know what's going on. Right. So they want to know there's a point A, B, what could be a value of a? Well, a is our x value. So to find out what could be a value for x, I need to know how far from left to right this circle goes. What are all its possible x values? Well, the center is here at negative 419, and my radius is 11. So I know it goes this way 11, and it also goes that way 11. It goes both directions by 11. So to find out the domain, that's our proper little term here, domain, the x values for this, how far to the left does it go? Well, it starts at negative 4 and it goes 11 to the left. So negative 4 minus 11 is negative 15. Then to the right, it starts at negative 4 and it goes towards the positive 11. So negative 4 plus 11, and that gives me 7. So I know that this circle goes from negative 15 all the way to 7, and there are values, x values within there that would be somewhere on this circle. So I'm going to look through my answers, and I'm going to look for something that's between negative 15 and 7, and there's only one option. That is B, negative 14. Everything else falls on either side of that, and that's it. So again, I think it's something where if you know your circle, your standard formula of a circle pretty well, and you can bring this up pretty quickly, that you could do like, oh, so 11 either way, minus 11 plus 11. Okay. You don't necessarily need Desmos. But again, you do you. We want you to feel comfortable, and the most important thing is just getting the answer right. Right? In this case, the right answer is B, negative 14. Number 23, a right rectangular prism has a height of 9 inches. All right, I'm going to draw a right rectangular prism. When it says a right prism, that just means it's a standard prism, and that, these sides that are coming down and forming right angles. And up at the top, it's a right angle as well. That's all it means. It's just the standard sort of prism that you've, learned about, read about, learned your formulas for. Okay, it has a height of 9 inches. Okay, so height of 9 inches, write that in. The length of the prism's base, sorry, my length and my width here. The length of the prism's base is x inches. Okay, x inches, which is 7 inches more than the width of the prism's base. Okay, now this is the key point, and this is the point where, some students are going to go the wrong way. I guarantee it. When it says the length is x inches, which is 7 inches more than the width, does that mean the width is x plus 7, or does it mean the width is x minus 7? Okay, when they're saying which is 7 inches more, which one of these? What are they talking about? They're talking about the length. The length is 7 inches more than the base. So to get, than the width of the base, excuse me. The length is 7 inches more than the width of the base. So to get from the width to the length, I need 7 inches more. So to get from width to length, I would need to add 7. However, my x is my length. So I'm starting at length and getting to width. So to do that, to go that way, I need to subtract 7. This is so easy to get tripped up on. Please read these problems carefully. They love disguising problems that you've done 1,000 times, but putting, different verbiage and wording to trip you up. They love it. They love it. They love it. Don't let them do it. Okay, so the length is 7 more than the width. So the width is 7 less than the length. So it is x, the length, minus 7. It is 7 less. All right, so now I have my 3 sides. I have my length, I have my width, and I have my height. And I'm going to reverse these. I'm going to write the x. Come here. There we go. X minus 7, and then that's my width. There we go. Now, which function v gives the volume of the prism in cubic inches in terms of the length of the prism's base? They're just meaning you don't have to solve for x. There would be no way to solve for x in this case, frankly. But when they're saying in terms of the length, we were told that the length was x. So they're saying you can just leave the x in there. Don't worry about trying to get rid of the x. That's what that means when they say in terms of the length. Just use the x. Okay, now volume. The volume of a rectangular prism is length times width times height. So this times this times this. Okay, so that's x times x minus 7 times 9. Now I can multiply these two together. 9 times x is 9x, and the x minus 7 stays there, and I could distribute it, but I'm going to look up here before I go any further and look at their answers, and none of these are distributed. They are still in these undistributed forms. And is there one that looks like what I just wrote? Absolutely there is. It's D. And look right there. Look at C. There's that x plus 7. Like I told you, they're going to try to trip you up with that x minus 7, x plus 7. Absolutely. Don't let them do it. It is D, 9x times x minus 7. Number 24. Which of the following functions has or have a minimum value at negative 3? Okay, so that's sort of the key. We're looking for a minimum value at negative 3. All right. Now, what functions do we have? We have f of x equals negative 6 times 3 to the power of x minus 3, then negative 3 times 6 to the power of x. And they want us to say, is this 1 only, 2 only, 1 and 2, or neither 1 nor 2? So I'll say this is a problem where your knowledge of some of the basic functions and their shapes will help you out a lot, by which I mean things like y equals x squared, parabola, y equals x cubed, looks like that. This is what I'm talking about, like those common functions you see a lot. And so this one, we have an exponential. Like exponential ones, select again for more options, select again for more options, select again for more options. Lordy. 3, 2, 1. Have a basic sort of, where it goes up to the sky like that. That's our normal sort of base form, like if it was something like y equals 2 to the power of x. That's what it would look like. And to the left, it would be approaching 0. And then to the right, it would be going into infinity. But let's get a more precise look at this. Let's go over to Desmos, and we're going to look at the basic sort of pattern we'll have with these functions, as well as these two particular ones. And again, remember, keep in mind we're looking for a minimum value of negative 3. So let's hop over to Desmos. Okay, so our first one I have here, I have f of x equals 3 to the power of x. And as you can see over here to the right, we are going to the sky. We're going up, up, up. And to the left, we're going down, down, down. Now here's something to be aware of with Desmos. Do you see how as I'm going down, it's getting smaller and smaller and smaller. This will not go on forever. Desmos sort of has a limit as far as how many it's going to go. And so look, okay, so it's at 4 zeros and 1. It's going to start showing 0. Is the value actually 0 there? No, it is not. It's getting smaller and smaller. It is approaching 0, but it never hits 0. But Desmos is not going to give you infinite decimals out to the right, so it cannot show that. Be aware of that for the future for similar problems, because it would be so easy for you to go, hey, like this one has a minimum value of 0. It doesn't. All right, let's look at the second version. This is when we add a addition or subtraction to the outside of that core, like 3 to the power of x, that core exponential. This is going to translate it down 3. That's what happens like when we had y equals x squared, and then it was y equals x squared minus 3. It takes that x squared and moves it down 3. So let's turn that on, and sure enough, there we go. We can see it's just moved that same function down 3. Now what if we put a negative in front of it? Negative 3 to the power of x. That is going to flip it across the x-axis. In this case, it's just going to turn it upside down wherever it's at. But in this case, because it's approaching 0, the original up here is approaching 0. This one down here is also going to be approaching 0 and getting smaller and smaller and smaller. But on the negative side, it's just a mirror image of it. So like if I say I had, show you again, like if I did this one, but I put a, turn that off, put a negative in front of it. See, it's going to, oh, negative. See, it's a mirror image of that one. It flips it across a horizontal line, a mirror across a horizontal line, that line that it's approaching. Okay, so our two that are from, here are the two that are actually from the problem. And what's going on with these two? They are on the left, they're each approaching a value but never crossing that line. This one, the g of x, the negative 3 times 6 to the power of x, is approaching 0. Even though Desmos doesn't show this, it's never crossing it or touching it. And then on the right-hand side, it is going downward into infinity. And our other one, that negative 6 times 3 to the power of x minus 3, it is approaching negative 3 and getting closer and closer. And there Desmos has led you astray by saying it actually is negative 3. It's not. It's very, very small distance away from negative 3, but it is negative 3.000000001, something like that. And then on the right, it's going into infinity. Now, when students see this, negative 3 and 0, I'm going to bet you there's going to be several people out there, quite a few I dare say, that are going to say, oh, negative 3, I see a negative 3 there. Negative 3 is what they're looking for, minimum value at negative 3. That's got to be it. But what does minimum value mean? A minimum is the smallest number, the lowest that it goes on the y-axis. Now look at these. These go on forever. They keep getting lower and lower and lower and lower. And keep going and going. And they're going to do that forever. There is no limit. There is no minimum. There's not even a maximum because it approaches negative 3 and it approaches 0, but it never hits it. It's always getting closer and closer and closer. So these exponentials, they don't have minimums and they don't have maximums. And that's what I was meaning before when I was talking about knowing the forms of the basic functions and what they do. Does a parabola have a minimum or a maximum? Yes. Yes, it does. So y equals x squared. Like there, does that have, this one has a minimum. It has that lowest y value. And if I put a negative in front of it, then it would have a maximum, the highest y value. Same with it was an x cubed. We could look at that and say, see what we know about an x cubed. Does that have a minimum or maximum value? Nope. To the left, it goes up into infinity, and to the right, it goes down into infinity. That's the negative version. Here's the positive. And that one, same one. It goes up into infinity, and then it goes down into infinity. It has no negative or maximum. Negative has no minimum or maximum. So, you know, these are, when we know these basic facts about our standard functions, it can help us. So just right here, as soon as we see it's an exponential, we go, wait a minute, it's asking for a minimum value. Exponentials don't have minimum or maximum values. They're approaching a line, an asymptote on one side, and they're going into infinity on the other. So no minimum or maximum. Okay. You wouldn't even have to put these into Desmos and fiddle around with it. You could just know that. So if we go back to our board, what is our answer going to be? Which of them has a minimum value at negative 3? Neither of them do. It is D. Neither 1 nor 2. Number 25. The result of increasing the quantity x by 400% is 60. What is the value of x? To increase something by 400%, let's go back a little bit and say, what would it mean if I increased x by 100%? 100% increase was I increased it by x times 100%. That would be a 100% increase. This is the amount you'd be increasing it by, and you are increasing the original by that amount, so you have to add them together. And this is 100%, which is the same as 1. If this was increasing x by 20%, you'd say, okay, what is 20% of x? And then I'm going to add that to the original value. So it would be x plus, convert it to a decimal, 0.20x. Now this one, it has been increased by 400%. All right, x plus 400% x. Right? So what is 400%? We change that to a decimal. That is 4. So I took the original value. I took what is 400% of x, and I increased that original value by 400%. And altogether, that equaled 60. And now I can solve for x. X plus 4x is 5x. 5 times x is 60. To undo that, I need to divide both sides by 5. So on the left I have x, and on the right 60 divided by 5 is 12. And let's just double check and see what were they asking. They're asking what is the value of x. Okay, 12. There it is. A is my answer. Always double check the question. Sometimes they like to change it and like they give you x and then they're like, but what is x times 10 or something? And you're like, how did I get the wrong answer? So double check that. But here it is. Direct value of x is 12, which is A. Number 26, the function f is defined by f of x equals ax squared plus bx plus c, where a, b, and c are constants. The graph of y equals f of x in the xy plane passes through the points 7, 0, and negative 3, 0. If a is an integer greater than 1, which of the following could be the value of a plus b? This is one of those sort of word salad problems that I think a lot of people start going, what? Because it's not like anything you've seen in your math book, most likely. Right, so f of x equals ax squared plus bx plus c. That is a parabola. And, you know, parabola can be a lot of things. We don't know what a, b, and c are, so it can be any of those. But we know basically the type of shape that a parabola is, right? And we're told that the graph of this function passes through the points 7, 0, and negative 3, 0. And I am not drawing this to scale. I'm just doing this to kind of... For myself, when I'm writing this is what I do. I was like, okay, give me an idea of what's going on. I'm not going to take the time during the SAT to make a scale drawing. And so negative 3, 0, and 7, 0. And the parabola passes through them. So this parabola could be going up and coming down. Or, there we go. Or it could be, oh goodness, this whiteboard. Or it could be going down and coming up. Either way, but it's going through these 2 points. These are its x-intercepts. When you know the x-intercepts, you know the zeros of it. So think about when we're factoring. If I had, say, in a different problem, let's say I had, you know, I factored something and I got it down to x minus 2 and x minus 3. I go, okay, I'm going to solve for x. So I split up x minus 2 equals 0. X minus 3 equals 0. I do my math. I figure out that x is 2 and x is 3. If I were to graph that, that parabola is going to go through the points 2, 0, and 3, 0. It just is. The zeros, where they solve, those are the x-intercepts. So let's go backwards. If the x-intercepts of 2 and 3 came from x minus 2 and x minus 3, well, here we have our x-intercepts of negative 3 and 7. So what would this factored thing look like? Well, it was the opposite, remember, because x, if it was 2, it was x minus 2. 3, it was x minus 3. So I know that this parabola, if it was factored, could be x plus 3 times x minus 7. Now, I want to get this into a form of ax squared plus bx plus c. So I'm going to distribute it. All right, so x times x is x squared. X times negative 7 is negative 7x. 3 times x is 3x. And 3 times negative 7 is negative 21. I'm going to combine those in the middle, and I get x squared minus 4x minus 21. And that, my friends, is a function that absolutely would work for this at first glance. Why do I say that? Because they've thrown a wrinkle into this. Because if you just glanced back at this point and said, what's the value of a plus b? You go, all right, a is 1, b is negative 4, add those together, negative 3, b is my answer. No, it's not. Why? Why isn't it? Because of this right here. It says if a is an integer greater than 1. There we go. Here, that integer, that invisible 1. Has to be greater than 1. So what's an integer greater than 1? What's the next one up? That'd be 2. So to change this to 2, I need to multiply this whole thing by 2, which would give me 2x squared minus 8x minus 42. Then when I added a and b, 2 plus negative 8 would be negative 6. And that is an option here. It is A. Another way you could look at this is when we had our first initial where we said 1 and -4 and you add them together. 1 plus -4 being -3. All of the possible values of A plus B would have to be a multiple of -3 because it's going to be multiplied by an integer greater than 1. So what you could do then at that point, instead of, trying 2, and then, hey, in this case particularly, it worked. Multiplying by 2 got us to -6, which was an answer, but they might not always be that kind. And I don't want you trying a whole bunch of integers in that case. So here we knew that it was -3, A plus B being -3. So we would look over here and see, are any of these multiples of -3, or does -3 go into any of them cleanly? And sure enough, A, it does. So A, -6 is the answer. All right, last but not least, 27. The function g is defined by g of x equals x times x minus 2 times x plus 6 squared. The value of g of 7 minus w is 0, where w is a constant. What is the sum of all possible values of w? Okay, now if I told you, let's forget about w for a second, or 7 minus w, let's forget about that for a second. What if it was just w? If I told you g of w is 0, means if and I don't know what number w is, means if I plug w, this unknown number, into this, I'm going to get 0. How could that be? Now, you know how when we're factoring, and if we were just factoring this and we had and I'm just going to do just the x minus 2 and the x plus 6, and I said that equals 0, that multiplied together equals 0, how do you solve for x? You assume either this equals 0 or that equals 0, because when you multiply them together to get 0, one of them has to. Same principle here, it just looks a little more complicated because we have 3 individual bits. And if I was just looking for w, I'd say, okay, well, either if I plug this number w in for x in these 3 locations, either this would have to equal 0, or that would have to equal 0, or that would have to equal 0, because I know when I plug this number w, this unknown number in, I get 0. Okay, now let's take it one further. We're saying it's not just w that when you plug in, it gets 0. It's 7 minus w. When I plug it in, I get 0. This still represents just a number because w is a constant. It's a number. So 7 minus a number is going to be just another number. So when I take this number, this whole number represented by 7 minus w, and I plug it in wherever there's an x, it's going to equal 0. So one of these locations has to equal 0. And the x plus 6 squared, don't really worry about the squared, because think of it as just being another x plus 6. So, doesn't matter which of those x plus 6s the 7 minus w would be in. You only have to look at one of them. Okay, so let's take each of these scenarios. What if it's the x? Putting 7 minus w in for x, that makes everything be 0. Well, then that must equal 0. So, okay, I plug in 7 minus w for x, so it's just now 7 minus w, and that may equal 0. All right, my second one here, 7 minus w for x, and then minus 2. That may equal 0. And then the last one, we have x plus 6. So, okay, 7 minus w in for x plus 6. That may equal 0. Now, I'm going to change the signs on all of these. Just so, there we go. Plus a negative, plus a negative. So we can combine like terms more easily. All right, so our first one, 7 minus w equals 0. I'm going to, or 7 plus a negative w equals 0. I'm going to add w to both sides, so things cancel out, and I get 7 on the left and just w on the right. So there's my first possible value of w is 7. The next one, I can combine 7 and negative 2. 7 and negative 2 is 5. So 5 plus a negative w equals 0. Same thing here. I'm going to add w to both sides, and I get that 5 equals w. And then this one, I have 7 plus a negative w plus 6, so I'm going to combine 7 and 6, combine those like terms, and 7 plus 6 is 13, plus a negative w equals 0. I'm going to do the opposite and add a w to both sides, and I get that 13 is equal to w. But what did they want to know? They said, what is the sum of all possible values of w? Well, we have 3 possible values. That is 7, 5, and 13. And when I add all of those together, I get my answer 25. And that's it. The sum of all possible values is 25, and you've done it. You've completed this. All 27 questions. Congratulations. Hey guys, just a quick heads up, I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe, you know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.